NGC 1300 continues to captivate astronomers with its intricate structure and the secrets it holds about the mechanisms driving galactic evolution. Its well-defined barred structure is a focal point for studying the transport of gas and angular momentum. The bar acts as a cosmic conveyor belt, guiding interstellar material toward the central regions where it accumulates, igniting bursts of star formation. This process is further evidenced by the glowing, clumpy regions along its spiral arms, teeming with young, luminous stars. The nucleus of this galaxy presents another layer of intrigue. Observations have revealed a tightly bound nuclear ring encircling the core, composed of vibrant, star-forming regions. These rings are thought to arise from the complex interplay of gravitational forces within the bar and the spiral arms, funneling gas into specific regions where it collapses to form stars. This nuclear activity offers a glimpse into how galactic cores evolve and sustain themselves over time. NGC 1300's bar also plays a role in shaping the overall rotation curve of the galaxy. Unlike simple disk galaxies, barred spirals like this one exhibit unique rotational dynamics, with the bar influencing the motion of stars and gas across the galactic plane. By studying these dynamics, astronomers gain valuable insights into the role of gravity in dark matter in maintaining the stability of such systems. Dark matter, though invisible, is a critical component of NGC 1300 structure. The motion of stars and gas indicates the presence of a massive dark matter halo that extends far beyond the visible galaxy. This unseen matter is crucial for explaining why the galaxy's outer regions rotate as rapidly as they do without flying apart. Understanding the distribution of dark matter in galaxies like NGC 1300 provides important clues about the nature of this mysterious substance that dominates the universe. Another fascinating aspect of NGC 1300 is its environment. Situated in the constellation Eridanus, it resides in a region of the sky populated by other galaxies. These neighboring systems may exert subtle gravitational influences on NGC 1300, potentially shaping its structure over billions of years. Such interactions, whether through close encounters or long-range gravitational effects, are key to understanding how galaxies evolve within their cosmic neighborhoods. NGC 1300's size is another remarkable feature, with its diameter stretching approximately 110,000 light-years, making it comparable to our own Milky Way. This immense scale allows astronomers to study the galaxy as a microcosm of the larger universe, with processes such as star formation, gas dynamics, and the effects of dark matter all playing out within its borders. Each of these processes offers a piece of the puzzle for understanding the broader mechanisms governing galaxies throughout the cosmos. Observations of NGC 1300, particularly through high-resolution imaging from instruments like the Hubble Space Telescope, have revealed additional structural details. Faint outer regions of the galaxy, including extended spiral arms and possible tidal streams, suggest a dynamic history involving past interactions or mergers. These features provide clues about the galaxy's past and the forces that have shaped it into the majestic structure we observe today. Under continued observation, NGC 1300 reveals itself as an unparalleled example of galactic complexity and beauty. Its spiral arms, extending symmetrically from the bar, showcase intricate patterns of star-forming regions. These arms are not just visually stunning but also act as laboratories for studying the physical conditions that drive the birth of stars. They contain vast amounts of gas and dust, the raw materials for star formation, interspersed with clusters of young, hot stars that illuminate their surroundings. The galactic core of NGC 1300 also provides a unique opportunity to explore the behavior of supermassive black holes. Although no active galactic nucleus has been detected within this galaxy, the presence of a central black hole is strongly theorized based on models of galactic evolution. Such black holes are often integral to a galaxy's life cycle, influencing the movement of stars and gas in the inner regions and regulating star formation through their gravitational pull. Moreover, the bar structure itself acts as a mechanism for redistributing angular momentum within the galaxy. This redistribution can lead to the gradual migration of stars and gas, shaping the long-term evolution of the galaxy's morphology. NGC 1300's bar is particularly notable for its length and prominence, making it an ideal subject for studies focused on the lifespan and eventual dissolution of these features in spiral galaxies. High-resolution images of NGC 1300 have also uncovered faint stellar streams and other evidence of past interactions with smaller satellite galaxies. These features suggest that, like many other galaxies, NGC 1300 may have undergone episodes of minor mergers or gravitational encounters, which have contributed to its current form. Such interactions are key to understanding how galaxies grow and evolve over cosmic time, building up their mass and altering their structure. The environment surrounding NGC 1300 in the Eridanus constellation is also of great interest. This galaxy resides in a relatively sparse region compared to dense galaxy clusters, yet it remains close enough to other systems to experience their gravitational influence. This positioning provides astronomers with an opportunity to study how galaxies like NGC 1300 interact with their surroundings in less crowded environments, offering a contrast to the more dramatic interactions seen in galaxy clusters. The continued study of NGC 1300 has revealed an array of dynamic processes occurring within its structure. The galaxy's spiral arms, rich in both molecular gas and interstellar dust, are prime regions for the study of star formation. Within these arms, dense pockets of gas collapse under the influence of gravity, giving rise to massive star clusters that light up the surrounding material. These clusters, in turn, influence the surrounding environment through stellar winds and supernova explosions, creating a cycle of destruction and renewal that drives the galaxy's evolution. The bar of NGC 1300, stretching prominently across its center, serves as a channel for gas and dust, funneling this material toward the inner regions of the galaxy. This movement often results in the formation of a circumnuclear ring, a structure observed in many barred galaxies, including NGC 1300. Within this ring, star formation activity reaches a peak, producing a concentrated burst of new stars. These regions are of particular interest to astronomers, as they provide a window into the processes that fuel the central activity of galaxies and, potentially, their central black holes. Another fascinating aspect of NGC 1300 is its rotational dynamics. Unlike the rigid body rotation seen in smaller objects, galaxies like NGC 1300 exhibit differential rotation, where the inner regions rotate faster than the outer regions. This differential motion plays a critical role in shaping the spiral arms and maintaining their structure over time. By analyzing the rotation curves of NGC 1300, scientists can gain a better understanding of how mass is distributed within the galaxy, including the contribution of dark matter. The dark matter halo surrounding NGC 1300 is a key area of study. Although this component of the galaxy is invisible, its gravitational effects are evident in the motion of stars and gas. The halo extends well beyond the visible edges of the galaxy, influencing its overall stability and rotation. Understanding the distribution and behavior of dark matter in galaxies like NGC 1300 is essential for unraveling the mysteries of this elusive substance, which makes up a significant portion of the universe's mass. In addition to its internal dynamics, NGC 1300's interactions with its cosmic environment provide further insight into its history. Although it is not part of a dense galaxy cluster, the galaxy's proximity to other systems suggests that it may have experienced gravitational interactions in the past. These encounters can trigger tidal forces that reshape the galaxy's structure, inducing bursts of star formation or altering the distribution of stars and gas. The majestic barred spiral galaxy, sometimes referred to as this cosmic masterpiece, continues to fascinate astronomers with its intricate architecture and dynamic processes. Its grand spiral arms, radiating outward from the central bar, reveal an ongoing symphony of stellar birth and evolution. The vibrant regions of star formation within these arms are home to young, luminous stars that illuminate the surrounding gas and dust, creating striking contrasts against the darker background of interstellar space. This celestial wonders bar, a defining characteristic of many similar galaxies, serves as a gravitational conduit, guiding interstellar material toward its core. This process not only fuels the star-forming regions near the nucleus, but also sheds light on how such structures influence the long-term development of galactic morphology. Observing these mechanisms within this galactic marvel offers valuable insights into the broader behaviors of barred spiral galaxies. At the heart of this astronomical phenomenon lies a tightly wound nuclear ring, a region teeming with intense star formation. This feature, observed in numerous galaxies of its type, results from the gravitational effects of the bar channeling gas into the central regions. Such regions are hotspots for scientific investigation, revealing how material accumulates to create bursts of star formation and, possibly, feed the central supermassive black hole. This stellar island, spanning over 110,000 light-years, exhibits complex rotational dynamics. The stars and gas within the system move in distinct patterns, shaped by the bar and the unseen influence of its dark matter halo. These rotation patterns are key to understanding the distribution of mass within this galactic giant, shedding light on the hidden forces that maintain its structure and stability. Beyond its visible structure, this cosmic enigma resides in a relatively sparse region of space within the constellation Eridanus. While not part of a dense galaxy cluster, this luminous spiral likely interacts with its neighboring galaxies, influencing its evolution through subtle gravitational effects. Such interactions might have played a role in shaping the features we see today, including its prominent bar and well-defined spiral arms. This stellar titan, often called a barred spiral masterpiece, offers a stunning glimpse into the vast complexities of the universe. Its brilliant spiral arms, stretching gracefully from the central bar, seem almost frozen in time, a cosmic snapshot of galactic evolution. Yet, within these serene structures lies a chaotic dance of creation and destruction. Massive, hot stars form in dense regions of interstellar gas, only to end their lives in powerful supernova explosions, scattering heavy elements that fuel the next generation of stars. The heart of this galactic wonder, marked by a glowing nuclear ring, pulsates with energy. This ring, composed of densely packed star-forming regions, is like a galactic engine, continuously producing new stars. Scientists believe this activity is driven by the central bar, which acts like a gravitational funnel, directing gas into the inner core. This unique feature makes the galaxy a prime subject for understanding how barred spirals sustain star formation over billions of years. Interestingly, this cosmic marvel holds clues to the secrets of galactic longevity. Its bar is not a permanent feature. It is believed that bars evolve and eventually dissolve, reshaping the galaxy into a more classical spiral or elliptical form. Studying the bar in this galactic gem provides a rare opportunity to witness a transitional phase in galactic evolution. Researchers are particularly fascinated by how the bar redistributes angular momentum, affecting the orbits of stars and the flow of gas throughout the galaxy. The rotational dynamics of this spiral leviathan are equally captivating. Unlike solid objects, galaxies rotate in a way that defies simple explanations. The outer regions move more slowly than the inner regions, yet the presence of dark matter stabilizes this differential rotation. By studying the velocity curves of this astronomical icon, scientists are unraveling the influence of dark matter, which remains one of the greatest mysteries of modern astrophysics. This universal masterpiece is not isolated, it resides in a vast cosmic neighborhood within the Eridanus constellation. The faint whispers of past interactions can be seen in the subtle distortions of its outer arms and the faint trails of stars that may mark the remnants of smaller galaxies it has absorbed. These signs of cosmic encounters tell the story of a dynamic past, where gravitational forces sculpted the galaxy into its current form. Moreover, this spiral behemoth's size is breathtaking. It spans over 110,000 light-years, comparable to the Milky Way. This immense scale makes it a microcosm of the universe, offering a window into the processes that shape galaxies on a grand scale. Each observation of this celestial jewel adds another piece to the puzzle of how galaxies grow, change, and interact with the cosmos around them. This luminous galactic titan, often referred to as a cosmic labyrinth of stars and dust, captivates not only with its mesmerizing beauty but also with the stories it tells about the universe's grand design. The spiral arms of this celestial marvel, adorned with star-forming regions and glowing clusters, appear almost like rivers of light flowing outward from the galactic center. Each arm is a testament to the forces of gravity and motion, which sculpt the galaxy's intricate structure over billions of years. What makes this barred spiral phenomenon even more fascinating is its ability to balance chaos and order. The bar, stretching boldly across its core, is not merely a decorative feature but a dynamic powerhouse. This structure channels gas inward, creating a bustling hub of activity in the nucleus, while simultaneously affecting the spiral arms. This process shapes the galaxy into the perfect blend of symmetry and complexity, a hallmark of a mature barred spiral galaxy. Within the glowing center of this stellar colossus lies a nuclear ring that bursts with youthful stars. These concentrated regions of intense star formation are fueled by gas funneled into the core by the bar's gravitational influence. The interactions between the bar, the ring, and the surrounding spiral arms create a rich tapestry of activity that astronomers study to uncover the secrets of galactic metabolism, the rate at which galaxies consume gas and form stars. Beyond its striking visual features, this universal giant serves as a natural laboratory for studying dark matter. The unseen halo surrounding the galaxy provides the gravitational glue that holds its luminous components together. Without dark matter, the galaxy's outer arms would spin apart due to their incredible speeds. By examining the motion of stars and gas in this stellar titan, researchers are gaining deeper insights into the elusive substance that makes up most of the universe's mass. Adding to the intrigue of this celestial spectacle is its location within the constellation Eridanus, where it resides in a relatively quiet but not isolated patch of the cosmos. Surrounding galaxies leave subtle imprints on its structure, offering clues about past gravitational encounters. These interactions may have triggered bursts of star formation or subtle shifts in the galaxy's structure, contributing to the majestic form we see today. On the edges of this spiral marvel, faint trails and distortions hint at a dynamic history of mergers and accretions. These faint features are like cosmic fingerprints, telling a story of smaller galaxies that were consumed over millions of years. Such events are key to understanding how larger galaxies, including this barred spiral giant, grow and evolve through the cosmic ballet of interactions. The immense scale of this stellar masterpiece, often referred to as a galactic titan, is matched only by the complexity of the processes within it. Stretching over 110,000 light-years across, this barred spiral colossus is a vibrant ecosystem of stars, gas, and dark matter. Its spiral arms, like flowing rivers of starlight, are shaped by density waves that propagate through the galaxy, compressing gas and dust into regions where stars are born. These arms are more than just aesthetic features, they are dynamic sites of stellar evolution, where the interplay of gravity, motion, and matter creates dazzling patterns of light and energy. The bar, a defining feature of this cosmic marvel, serves as a critical driver of its internal dynamics. Extending through the galaxy's center, the bar acts like a gravitational engine, redistributing gas and stars. It funnels interstellar material into the core, feeding the central regions and potentially sustaining the activity of a supermassive black hole. Although this black hole remains hidden from direct observation, its presence is inferred from the galaxy's overall structure and the movement of stars near its nucleus. The nuclear ring within this celestial labyrinth is another highlight of its dynamic nature. This tightly packed region of active star formation is thought to be fueled by the bar's influence. The gravitational forces at play concentrate gas into the central regions, creating a fertile environment for the birth of massive, short-lived stars. These stars emit intense ultraviolet radiation, lighting up the surrounding gas and creating the glowing rings and patches observed in high-resolution images of the galaxy. This spiral wonder is also a fascinating subject for studying the influence of dark matter. While its luminous features are breathtaking, the hidden dark matter halo is what holds the galaxy together. Without this invisible mass, the outer regions of the galaxy would not rotate at the speeds observed. By analyzing the motion of stars and gas within the galaxy, scientists can map the distribution of dark matter, gaining critical insights into one of the universe's greatest mysteries. The cosmic history of this galactic marvel is written in its structure. Faint distortions in its outer arms and the presence of tidal streams suggest a history of interactions with smaller galaxies. These gravitational encounters leave behind subtle signatures, such as warped arms or faint trails of stars, which astronomers use to reconstruct the galaxy's past. Each merger or interaction adds to the richness of its structure, contributing to the majestic form we see today. Beyond its internal processes, this barred spiral galaxy is part of a larger cosmic tapestry. It resides in the Eridanus constellation, a region known for its diverse population of galaxies. Though it is not part of a dense galaxy cluster, its interactions with nearby systems influence its evolution. These interactions can trigger bursts of star formation or alter the distribution of stars and gas, shaping the galaxy over billions of years. The sheer scale and complexity of this spiral masterpiece make it an invaluable subject for astronomers. Its well-defined bar and spiral arms, active star-forming regions, and dynamic interactions with its surroundings offer a glimpse into the forces that shape galaxies across the universe. Every observation of this stellar titan adds another layer to our understanding of how galaxies like it evolve, interact, and adapt over cosmic time. This galactic marvel, often described as a cosmic colossus, offers an infinite reservoir of mysteries waiting to be unraveled. Its spiral arms, stretching like graceful bridges between the outer edges and the central bar, are home to some of the most dynamic and vibrant star-forming regions in the known universe. These arms are sculpted by density waves, large-scale gravitational phenomena that compress gas and dust as they propagate, triggering the formation of young, massive stars that illuminate the surrounding regions in hues of blue and white. The central bar of this universal masterpiece is not merely a static structure but a living, evolving feature. This bar acts as both a channel and a regulator, directing material inward while redistributing angular momentum outward. This constant flow of interstellar gas provides the fuel for the galaxy's star-forming regions and sustains the activity in its nuclear ring, a zone where the interplay between gravity and turbulence creates a bustling hub of stellar activity. Observing this process in such detail allows scientists to piece together how bars in galaxies like this one form, evolve, and eventually dissolve. One of the most intriguing aspects of this spiral titan lies in its hidden heart. While the central region appears bright and active, it may harbor a supermassive black hole, an enigmatic feature that could govern the dynamics of the galaxy's nucleus. Although there is no evidence of an actively feeding black hole in this barred spiral giant, its gravitational influence could subtly shape the motion of stars and gas within the inner regions. Studying this potential feature can reveal how such objects interact with their host galaxies over time, shaping their growth and evolution. The outer edges of this celestial giant also hold secrets about its past. Faint tidal streams and distorted structures suggest that it has experienced gravitational encounters with smaller galaxies or intergalactic clouds. These interactions may have left scars on its structure, subtly warping its arms or triggering bursts of star formation. These clues offer a window into the galaxy's evolutionary journey, showing how it has grown and adapted through mergers and interactions over billions of years. In addition to its internal features, this stellar giant's location within the constellation Eridanus places it in a fascinating cosmic neighborhood. Surrounded by a sparse yet diverse collection of galaxies, it is part of a dynamic environment that influences its behavior. Gravitational interactions with neighboring systems, even at great distances, can affect the shape of its spiral arms, the distribution of its stars, and the rate of star formation. This cosmic interconnectedness illustrates how galaxies are not isolated entities but are deeply intertwined with their environments. The study of this galactic masterpiece also extends to the unseen components that govern its dynamics. The role of dark matter, an invisible substance that permeates the universe, is especially significant in this barred spiral galaxy. Without the stabilizing influence of a massive dark matter halo, the galaxy's outer regions would not be able to maintain their rapid rotation. By analyzing the motion of stars and gas in the galaxy, astronomers can map the distribution of this mysterious substance and better understand its role in shaping the universe. This cosmic jewel's size alone is awe-inspiring. Spanning over 110,000 light-years, it rivals the Milky Way in scale and complexity. Its grand structure, from the luminous central bar to the sweeping spiral arms, serves as a natural laboratory for studying the processes that drive galactic evolution. Every observation of this spiral giant reveals new layers of complexity, helping scientists answer fundamental questions about the origins and fate of galaxies across the cosmos. This galactic titan, a sprawling cosmic tapestry of stars, gas, and mystery, is a playground for astronomers seeking to understand the forces that shape the universe. Its spiral arms, glowing with the light of newly formed stars, tell the tale of an ongoing cosmic ballet. These arms, rich with molecular gas and interstellar dust, are not static, they constantly churn and evolve, shaped by density waves that ripple through the galaxy. As these waves compress the gas, they create stellar nurseries where stars of all sizes are born, illuminating the galaxy like scattered jewels. The central bar of this celestial masterpiece is a dynamic and transformative feature. Acting as a galactic highway, it channels gas and dust inward, fueling the active core and potentially feeding the supermassive black hole thought to reside at the heart of the galaxy. The bar's gravitational influence also orchestrates the flow of material in the spiral arms, ensuring the galaxy maintains its symmetrical beauty. The sheer scale of this bar, stretching tens of thousands of light-years, makes it a dominant and mesmerizing feature, a bridge between the galactic core and its sprawling outskirts. At the very heart of this barred spiral giant lies a nuclear ring, a glowing, active hub of star formation that serves as a cosmic engine. This ring is where gravity and turbulence collide, concentrating vast amounts of gas into regions dense enough to ignite the birth of stars. The stars in this region are often young and massive, their intense radiation lighting up the surrounding gas clouds and creating a spectacle visible across millions of light-years. Observing this region helps astronomers understand the mechanisms behind intense starbursts and the life cycles of galaxies. Beyond its striking visible features, this galaxy holds a secret, the hidden realm of dark matter. While its stars and gas form the visible structure, they are merely the tip of the iceberg. Encasing this spiral beauty is a massive halo of dark matter, invisible to telescopes but essential for the galaxy's existence. This dark matter provides the gravitational glue that holds the galaxy together, preventing its outer edges from flying apart despite their rapid rotation. Studying the motion of stars and gas within the galaxy allows astronomers to map the distribution of this mysterious substance and explore its role in shaping cosmic structures. But this barred spiral isn't just a solitary wonder, it is part of a larger cosmic web. Its location in the constellation Eridanus places it in a sparsely populated region of the universe, yet it is not alone. Neighboring galaxies, some visible and others faintly detectable, interact with this galactic giant through gravitational forces. These interactions, whether past or present, leave subtle imprints on its structure, from distorted spiral arms to faint streams of stars that hint at ancient mergers. These clues offer a glimpse into the galaxy's dynamic past, a history written in the stars themselves. On the fringes of this cosmic giant, faint distortions in the spiral arms and wisps of tidal debris tell the story of a galaxy shaped by time and interaction. These remnants are the echoes of encounters with smaller galaxies, events that added mass to this spiral titan and contributed to its stunning complexity. Such mergers and accretions are common in the universe, illustrating the interconnectedness of galaxies and their shared evolutionary journeys. This barred spiral marvel is more than just a visual spectacle, it is a cosmic laboratory where the forces of gravity, motion, and energy come together in a delicate balance. Its intricate structure, from the glowing core to the sweeping arms, provides astronomers with invaluable insights into the mechanics of galactic evolution. Every star, every stream of gas, and every faint tidal remnant is a piece of a puzzle that tells the story of how galaxies like this one grow, adapt, and thrive in the ever-changing universe. This galactic titan, sometimes called a celestial symphony of light and motion, continues to amaze with its endless layers of complexity. Its sweeping spiral arms, sprawling outward like vast bridges through the void, are not only beautiful but essential to understanding how galaxies like it evolve. These arms are the sites of constant transformation, where the raw ingredients of the cosmos, gas, dust, and dark matter, combine to create new generations of stars. The interplay between gravity and motion within these arms results in an ever-changing cosmic dance that has persisted for billions of years. At the core of this spiral giant, the bar serves as a mechanism of cosmic engineering. This elongated structure is not just a static feature but a living, dynamic force within the galaxy. It acts as a gravitational conveyor belt, pulling material inward toward the central regions. This inflow of gas feeds the nuclear ring, a zone of intense star formation near the galaxy's center. Here, massive stars are born in rapid succession, their short lives punctuated by brilliant supernova explosions that enrich the surrounding gas with heavy elements. These elements will eventually form the building blocks of planets, moons, and possibly even life in distant star systems. The nuclear ring, glowing like a halo around the galaxy's heart, is one of its most fascinating features. It is a region where the forces of compression and turbulence collide, creating perfect conditions for the rapid birth of stars. Observing this process in such detail provides astronomers with a rare opportunity to study the mechanisms behind galactic starbursts, moments of intense star formation that shape the character of a galaxy over time. In this ring, the interplay between gravity and gas density creates a self-sustaining cycle of stellar creation and renewal. Beneath the visible beauty of this spiral masterpiece lies the invisible hand of dark matter. Encasing the galaxy is a massive dark matter halo that plays a critical role in its evolution. While this dark matter cannot be seen, its effects are profound, shaping the rotation curves of the galaxy and holding its luminous components together. Without the stabilizing influence of dark matter, the galaxy's delicate structure would unravel, and its outer arms would spin apart into the cosmic void. The study of this hidden component provides a window into one of the universe's greatest mysteries, the nature of the unseen matter that dominates its mass. The outer regions of this galactic marvel tell another story, one of cosmic interactions and ancient collisions. Faint distortions in its spiral arms and barely visible tidal streams suggest a history of encounters with smaller galaxies. These interactions, though subtle, have left permanent marks on the galaxy's structure, warping its outer edges and possibly triggering bursts of star formation in the past. Each of these encounters is like a chapter in the galaxy's life story, a record of how it has grown and adapted over billions of years. This barred spiral beauty resides in a relatively quiet part of the universe, within the constellation Eridanus. However, its cosmic neighborhood is not without influence. Gravitational forces from nearby galaxies, even those far removed, can subtly affect its shape and motion. These interactions remind us that no galaxy exists in isolation, instead, each one is part of a larger cosmic web, constantly influenced by its surroundings. The sheer size of this galactic wonder, spanning over 110,000 light-years, makes it an awe-inspiring subject for study. Its scale, comparable to that of the Milky Way, allows scientists to investigate processes that occur on both local and cosmic levels. From the tiniest star-forming regions within its arms to the grand sweep of its dark matter halo, every aspect of this galaxy contributes to our understanding of the universe. This cosmic titan is not just a static entity frozen in time, it is a living system, constantly changing and evolving. The cycles of star formation, the movement of gas through its spiral arms, and the gravitational interactions with its surroundings all demonstrate the dynamic nature of galaxies. Each observation of this barred spiral masterpiece adds a new piece to the puzzle of how galaxies like it form, grow, and thrive over the lifetime of the universe. When compared to other galaxies, this barred spiral giant stands out as an exemplar of complexity and harmony in galactic evolution. Unlike the simpler elliptical galaxies or irregular systems scattered across the cosmos, this galactic masterpiece showcases the intricate dynamics of a well-developed spiral galaxy with a central bar. These characteristics place it in a class of galaxies that serve as essential models for understanding how structure, motion, and energy interact over billions of years. One fascinating comparison can be drawn between this cosmic giant and our own Milky Way galaxy, which also features a central bar and sprawling spiral arms. While both galaxies share many structural similarities, such as the presence of star-forming regions and a likely supermassive black hole at their cores, each exhibits unique variations that make them valuable for study. For instance, the bar in this galactic titan is particularly prominent, suggesting it might be at a later stage in its evolutionary life cycle compared to the Milky Way. This raises questions about the lifespan of bars in spiral galaxies and their role in shaping long-term galactic dynamics. Another intriguing aspect is how this barred spiral compares to galaxies without bars. Spiral galaxies lacking bars tend to distribute gas and stars more evenly, while those with bars, like this one, create a more directed flow of material toward the core. This difference significantly impacts star formation and the growth of central supermassive black holes. In this barred beauty, the bar acts almost like a cosmic engine, driving material inward and fueling the intense activity observed in its nuclear ring. By studying these contrasts, astronomers can better understand the various pathways galaxies take as they evolve. This spiral wonder is also an excellent example of a grand design galaxy, a term used to describe systems with highly symmetrical and well-defined spiral arms. Such galaxies are thought to be influenced by large-scale density waves, which create the stunning patterns we observe. In contrast, flocculent spiral galaxies have less organized and patchy arms, making them appear more chaotic. The symmetrical nature of this galaxy's arms suggests that it has experienced relatively stable conditions, allowing these density waves to shape its structure over time. However, faint tidal distortions hint that even this seemingly serene giant has a dynamic past filled with interactions and changes. The broader cosmic web surrounding this galactic titan also plays a crucial role in its evolution. Unlike galaxies located in dense clusters, where interactions are frequent and often violent, this spiral resides in a less crowded region, allowing it to maintain its graceful structure. Yet, even in this quieter setting, gravitational interactions with neighboring systems have likely influenced its form. These subtle encounters, often stretching over millions of years, contribute to the galaxy's story, shaping its spiral arms, triggering star formation, and possibly altering the trajectory of its bar. Interestingly, this barred spiral galaxy is also a key player in the study of galactic feedback processes. Feedback refers to how energy and matter expelled by stars and black holes impact the surrounding environment. In the case of this galaxy, stellar winds, supernova explosions, and potentially even outflows from its central black hole interact with the surrounding gas, regulating star formation. This delicate balance ensures the galaxy doesn't burn through its gas too quickly, allowing it to sustain star formation over billions of years. The study of this cosmic marvel has also shed light on the fate of galaxies with bars. While the bar is a prominent feature now, it is not permanent. Over time, the redistribution of angular momentum and the inflow of material may weaken the bar, eventually causing it to dissolve. This transformation could lead to a more traditional spiral galaxy or even an elliptical form, depending on external influences such as mergers or interactions. Observing this barred titan provides astronomers with a snapshot of a galaxy in transition, offering clues about the long-term life cycles of barred spirals. This grand barred spiral, a cosmic symphony of light and motion, invites speculation about its future and the larger story of its role within the evolving universe. Like all galaxies, this one is not static, it is a living entity shaped by time, gravity, and its surrounding environment. While its current structure is dominated by the bold bar and sweeping spiral arms, its ultimate fate may look vastly different, offering tantalizing clues about how galaxies transform over cosmic timescales. In the far future, the bar at the galaxy's center, now a striking and dynamic feature, may begin to fade. Bars are not permanent, they are thought to evolve over billions of years, gradually dissolving as the redistribution of angular momentum reshapes the galaxy. As stars and gas migrate outward from the bar, its structure could weaken and give way to a more classical spiral shape. Alternatively, external influences such as interactions with nearby galaxies could accelerate this process, further disrupting the bar's stability and possibly triggering a major reorganization of the galaxy's structure. The spiral arms, too, are in constant motion, slowly changing as density waves move through them. Over time, as the gas supply dwindles, these arms may become less pronounced, fading into a more uniform disk. This would mark a significant shift in the galaxy's life cycle, as star formation slows and it transitions into a quieter, more stable phase. Such a future reflects the natural aging process of galaxies, where periods of intense activity eventually give way to calmer, less dynamic states. This galactic masterpiece is also part of a much larger narrative, the evolution of the universe itself. As the cosmos continues to expand, the space between galaxies grows, making interactions less frequent over immense timescales. However, for this barred spiral, its relative proximity to other galaxies means it may still experience gravitational encounters in the distant future. These encounters could lead to dramatic mergers, reshaping the galaxy entirely and forming a new, larger system. Such mergers are common in the universe and often lead to the formation of elliptical galaxies, giant, featureless structures dominated by older stars. At the galaxy's core, the presence of a supermassive black hole adds another layer of intrigue to its future. While currently dormant or relatively inactive, this black hole could awaken if enough gas and material are funneled into its vicinity. Such activity would transform the galaxy's nucleus into a quasar or active galactic nucleus, emitting intense radiation altering the surrounding environment. Even in its current state, the black hole subtly influences the motion of stars and gas near the core, acting as a gravitational anchor for the entire system. Beyond its internal evolution, this barred spiral is part of the cosmic web, a vast network of galaxies, clusters, and filaments that stretches across the universe. Its interactions with this larger structure provide insights into the role of individual galaxies in shaping the universe's overall architecture. For instance, the faint tidal streams and distorted features in its outer regions suggest past mergers or accretions, events that contribute to the growth of galaxies and the redistribution of matter on a cosmic scale. The study of this galactic wonder also raises questions about the long-term behavior of dark matter. Encased in an invisible halo of dark matter, this galaxy relies on this mysterious substance to maintain its structure and rotation. As our understanding of dark matter deepens, astronomers hope to uncover how these halos evolve and interact with the visible components of galaxies. This could lead to groundbreaking discoveries about the fundamental forces that govern the universe. Ultimately, this barred spiral is more than just a single galaxy. It is a window into the mechanisms that have shaped the cosmos for over 13 billion years. From the intricate dynamics of its bar and spiral arms to the hidden influences of dark matter and the potential of future mergers, every aspect of this galaxy tells a story of creation, transformation, and the ongoing dance of matter and energy in the universe. The deeper we dive into the story of this magnificent barred spiral galaxy, the more profound its connection to the cosmos becomes. Its role is not just that of an isolated star system, but as an active participant in the grand drama of universal evolution. From its bar and spiral arms to its hidden dark matter halo, each component is a piece of a larger puzzle that reveals the intricate relationships between matter, energy, and time. At the heart of this galaxy lies its most enigmatic and powerful feature, the supermassive black hole. Though it remains quiet now, it holds the potential to dramatically alter the galaxy's fate. If sufficient gas and dust are funneled into its gravitational pull, perhaps through a future galactic interaction, the black hole could erupt into activity, transforming the galaxy into a quasar. This phase would be marked by the release of intense jets of energy, capable of affecting star formation across the entire galaxy. Such phenomena highlight the incredible influence of these cosmic giants, even when their presence is invisible. The bar itself, a cosmic sculpture of structure and motion, is a temporary yet transformative feature. Studies of galaxies like this one suggest that bars are a middle chapter in the life story of spiral galaxies. They form when gravitational instabilities cause stars and gas to align into elongated shapes, redistributing angular momentum and creating the intricate patterns seen in the spiral arms. Over time, however, the bar may dissipate, leaving behind a more uniform disk. Observing this barred galaxy offers a snapshot of this transitional phase, revealing how galaxies shift between states over billions of years. One of the most fascinating aspects of this galactic masterpiece is its potential for future interactions. While it currently resides in a relatively quiet region of the universe, its gravitational pull ensures it remains connected to other galaxies in its vicinity. Future encounters with smaller galaxies or intergalactic clouds could trigger a cascade of changes, from bursts of star formation to the eventual merger of systems. Each interaction would add to the galaxy's mass and complexity, further enriching its already intricate structure. Even now, the outer edges of this spiral wonder bear the marks of its dynamic past. Faint tidal streams, barely visible against the darkness of space, suggest that this galaxy has absorbed smaller systems over time. These mergers, while subtle, are essential to the growth of galaxies, allowing them to accumulate stars, gas, and dark matter. These events leave behind not only structural scars but also a story of survival and adaptation, as the galaxy integrates these new components into its overall framework. This barred spiral's role in the larger cosmic web is another layer of its significance. As part of this interconnected network of galaxies and filaments, it contributes to the flow of matter and energy across the universe. Gravitational interactions between galaxies within this web help shape their evolution, guiding the formation of stars and the distribution of dark matter. This galaxy, like all others, is both an individual entity and part of a much larger system, illustrating the dual nature of the universe as both fragmented and unified. The interplay between visible and invisible matter in this galaxy is another profound mystery. Its luminous stars and glowing gas are merely the surface of its existence. Encased within a vast dark matter halo, this galaxy's structure and stability are deeply tied to forces we cannot see. Dark matter, though elusive, provides the gravitational framework for the galaxy's rotation and growth. Without it, the spiral arms and bar would not hold their shape, and the galaxy would collapse under its own motion. The future of this galactic titan, like all galaxies, is one of inevitable change. Over billions of years, its gas will be consumed or expelled, its star formation will slow, and its structure will shift. Whether it evolves into a more traditional spiral galaxy, merges into a larger system, or transitions into an elliptical galaxy depends on the complex interplay of internal dynamics and external forces. Each possible path offers new opportunities for discovery, as astronomers continue to piece together the life cycles of galaxies across the cosmos. This barred spiral galaxy is a reminder of the universe's ceaseless creativity. It is a snapshot of cosmic evolution, a living system in the midst of its journey through space and time. From its glowing core to its faint outer edges, every aspect of this galaxy tells a story of formation, transformation, and survival in a universe that is constantly in motion. This barred spiral galaxy, a masterpiece etched into the fabric of the cosmos, is more than a celestial object, it is a testament to the universe's infinite capacity for beauty and complexity. Its structure, from the radiant core to the farthest reaches of its spiral arms, is a symphony of creation, destruction, and rebirth that has played out for billions of years. To gaze upon it is to witness a story that stretches across eons, written in the language of stars, gas, and unseen forces. The spiral arms of this galactic wonder, like flowing rivers of starlight, are where some of the universe's most dramatic events unfold. Here, interstellar clouds of gas and dust are compressed by density waves, triggering the birth of stars in spectacular stellar nurseries. Massive, luminous stars emerge in these regions, their intense radiation sculpting the surrounding material into glowing nebulae. These stars live fast and die young, ending their lives in powerful supernova explosions that enrich the galaxy with heavy elements, the seeds for future stars, planets, and perhaps even life. At the galaxy's heart lies its luminous bar, a structure that defies the stillness of the cosmos. This bar is not a relic of the past but an active force, shaping the flow of matter and energy within the galaxy. It serves as a gravitational engine, driving gas inward toward the nucleus and outward into the spiral arms. This process fuels both the galaxy's core and its star-forming regions, creating a delicate balance that sustains its vibrant activity. The bar itself is a transient feature, a fleeting phase in the galaxy's life cycle that will one day fade, leaving behind a different form altogether. But the nucleus of this cosmic giant is where its mysteries deepen. Within the central regions, a supermassive black hole may reside, a silent titan whose gravitational pull shapes the motions of stars and gas in its vicinity. Though dormant now, this black hole holds the potential to awaken, unleashing jets of energy that could reshape the galaxy's inner structure. This hidden power at the core is a reminder of the duality of galaxies, places of creation and destruction, where light and shadow coexist in an eternal dance. Encasing the galaxy is its dark matter halo, an invisible scaffolding that provides the gravitational foundation for its existence. Dark matter, though unseen, is the silent architect of the universe, holding galaxies together and guiding their rotation. Without it, the galaxy's delicate spiral arms and bar would disintegrate, leaving chaos in their wake. Studying this hidden component offers a glimpse into the fundamental forces that govern the cosmos, bridging the gap between the known and the unknown. Beyond the galaxy itself lies the vastness of the cosmic web, a network of galaxies, clusters, and filaments that stretches across the universe. This barred spiral, though unique, is one node in this immense structure, its interactions with neighboring galaxies shaping both its destiny and that of the surrounding space. These interactions, whether through gentle gravitational pulls or dramatic mergers, leave imprints on the galaxy's structure, faint tidal streams, warped arms, or bursts of star formation that echo through time. In the far future, this galactic marvel will undergo profound transformations. As its gas reserves dwindle, star formation will slow, and its spiral arms may fade into a featureless disk. Its bar, once a bold centerpiece, will dissolve, and the galaxy may merge with others, becoming part of a larger system. These changes are not losses but transitions, as the galaxy continues its journey through the cosmos, evolving in response to the forces that surround it. This barred spiral galaxy is a window into the universe's endless creativity, a living testament to the forces that shape and sustain the cosmos. Its luminous beauty, dynamic processes, and hidden mysteries remind us that the universe is not a static place but a realm of constant motion and transformation. Every observation of this celestial wonder adds another layer to its story, deepening our understanding of the universe and our place within it. This barred spiral galaxy, a cosmic masterpiece suspended in the vast darkness of space, is a reminder of the infinite wonders that unfold in the universe. Its existence speaks to the ceaseless power of gravity and time, shaping its structure, igniting its stars, and weaving its story into the grand narrative of the cosmos. It is not just a galaxy, it is a living, breathing tapestry of creation, bound by forces both visible and invisible. The spiral arms of this stellar titan, shimmering with clusters of newborn stars, stretch like luminous pathways through the cosmic void. These arms are home to some of the most dramatic events in the galaxy. In dense regions of interstellar gas and dust, gravity takes hold, collapsing clouds into fiery star-forming regions. Massive blue stars, brilliant and short-lived, emerge to illuminate their surroundings, their ultraviolet radiation carving glowing shapes into the nebulous material. These stars live their lives in the blink of an eye on cosmic scales, ending in explosive supernovae that scatter heavy elements into space. These elements, the building blocks of planets and life, are the galaxy's gift to the universe, a cosmic cycle of death and rebirth that echoes through time. Yet the galaxy's story is not only one of creation but also of dynamic motion. Its bar, a structure of immense scale, dominates the galaxy's core, acting as a gravitational bridge between the nucleus and its spiral arms. This bar is a cosmic engine, driving the flow of gas and dust inward toward the central regions. Here, The material collects in a nuclear ring, a glowing ring of star-forming activity that encircles the galactic heart. This ring, a hotspot of youthful stars and turbulent energy, represents the dynamic relationship between the bar's influence and the galaxy's natural cycles. Observing this process provides astronomers with a rare glimpse into how galaxies sustain themselves, balancing destruction and creation in a cosmic rhythm. Deep within the nucleus lies the galaxy's most enigmatic and powerful force, a supermassive black hole. Though invisible to the eye, its presence is felt in the motion of stars and gas that orbit near its event horizon. This black hole is a paradox, a region of ultimate darkness surrounded by the brightest regions of the galaxy. While dormant now, it holds the potential to awaken, transforming the galaxy into an active powerhouse, with jets of radiation capable of altering the structure and energy balance of its surroundings. This duality, of silence and fury, is a testament to the extremes of the universe. Beyond the galaxy's luminous features lies the silent, unseen hand of dark matter. This mysterious substance, which makes up the majority of the galaxy's mass, forms an invisible halo that stretches far beyond the visible spiral arms. Dark matter provides the gravitational framework for the galaxy's rotation, ensuring its outer regions do not spiral out into the void. Though it cannot be observed directly, its influence is undeniable, and its presence raises profound questions about the nature of the universe. What is dark matter? How did it come to shape the cosmos? These questions drive some of the most ambitious scientific inquiries of our time. The galaxy's story is also one of connection. It is not an isolated island in the universe but a part of the cosmic web, a vast network of galaxies linked by the force of gravity. This web, stretching across billions of light-years, connects galaxies in clusters, filaments, and voids, shaping the universe on the largest scales. The faint distortions in this galaxy's outer regions, tidal streams, warped arms, are the scars of past interactions with smaller galaxies. These encounters are reminders of the galaxy's dynamic history, moments of transformation that have added to its complexity and beauty. Looking to the future, the destiny of this barred spiral galaxy is one of inevitable change. Over billions of years, as its gas is consumed or expelled, its ability to form new stars will wane. The bar, a transient feature, will fade away, leaving behind a smoother, more uniform structure. The spiral arms may dissolve, their light dimming as the galaxy transitions into a quieter phase of existence. Eventually, it may merge with another galaxy, its identity blending into a larger system. This is the nature of the universe: change, adaptation, and renewal. But even as it evolves, this galaxy will remain a source of wonder and knowledge. Each observation reveals more about the forces that govern the universe, from the physics of star formation to the mysteries of dark matter. Its story is one of endless discovery, a reminder that the cosmos is as much about questions as it is about answers. This barred spiral galaxy is more than a celestial marvel, it is a riddle wrapped in light and shadow, a labyrinth of cosmic secrets waiting to be unraveled. Every facet of its existence holds a deeper truth, a clue to the forces that sculpt the universe. From its dazzling spiral arms to the unseen depths of its dark matter halo, it invites us to question everything we think we know about the cosmos. One of the most intriguing mysteries lies within the galaxy's bar, a structure that seems both permanent and transient, steady yet dynamic. Why do bars form in some galaxies and not in others? What cosmic hand decides whether a galaxy becomes a grand design spiral, a chaotic flocculent, or an unassuming elliptical. This bar, stretching tens of thousands of light-years, may hold the answer. Acting as a gravitational conveyor belt, it funnels gas inward while flinging stars outward, creating a balance of motion that appears almost deliberate. Yet this balance is fragile. A subtle nudge, a passing galaxy, a shift in dark matter, could send it spiraling into chaos. The core of the galaxy, shrouded in mystery, is a cosmic paradox. It is home to a supermassive black hole, a region where gravity is so intense that not even light can escape. And yet, surrounding this void is a nuclear ring teeming with life, massive stars being born, shining brilliantly for millions of years before dying in spectacular explosions. How can such a lifeless force coexist with such creation? This delicate interplay between destruction and birth raises profound questions about the nature of the universe itself. Is chaos necessary for creation? Is the galaxy's heart a mirror of the universe, where order and disorder dance together in perpetual harmony? Even the spiral arms, those iconic structures of beauty, are riddled with puzzles. These arms are not static, they are waves of density, rippling through the galaxy like cosmic tides. But what drives these waves? Are they the echoes of past galactic collisions, remnants of ancient gravitational encounters? Or are they self-sustaining phenomena, perpetuated by the stars and gas that flow through them? Within these arms, new stars are born, but not randomly. They seem to form in bursts, clustered together as if guided by an unseen hand. What governs this process? Could the influence of dark matter, hidden but ever-present, be the silent architect of these patterns? The galaxy's dark matter halo is perhaps its greatest enigma. This invisible cocoon, vast and unmeasurable directly, is the foundation of the galaxy's existence. Without it, the galaxy would fall apart, its stars and gas would drift into the void. Yet we know so little about dark matter, what it is, where it comes from, and why it behaves as it does. Does it hold the key to understanding the universe's origins? Is it the missing piece of a cosmic puzzle we have yet to fully grasp? As we study the rotation of this galaxy's stars, we are not just observing motion, we are decoding the fingerprints of a force that has shaped the universe since the beginning of time. And what of this galaxy's future? It is a titan now, a luminous giant in the cosmic night. But time spares no one, not even galaxies. Its bar will fade, its gas will run dry, and its spiral arms will grow faint. In billions of years, it may collide with a neighboring galaxy, their structures merging into a chaotic swirl before settling into a new form, perhaps an elliptical galaxy, quiet and subdued. Or it may end in isolation, drifting through an ever-expanding universe where stars burn out one by one, leaving behind only darkness. Yet even in its eventual demise, this galaxy's legacy will endure. The stars it forged, the elements it scattered, the planets it may have nurtured, all will become part of a greater cosmic story. Its matter will not disappear, it will be recycled, forming new stars, new galaxies, and perhaps even new life. This is the ultimate truth of the universe: nothing is lost, only transformed. This barred spiral is not just an object to observe, it is a question to ponder, a story to uncover, and a wonder to behold. Its existence reminds us that the universe is not static but alive with motion, change, and mystery. Every flicker of starlight, every ripple of gas, every hidden strand of dark matter is a clue, a whisper from the cosmos, inviting us to look deeper, think bigger, and dream farther. This barred spiral galaxy, a cosmic tapestry woven from light, shadow, and mystery, stands as a monument to the boundless creativity of the universe. Its story, written over billions of years, is one of ceaseless transformation, a cycle of creation, destruction, and renewal that mirrors the very essence of existence itself. As we study its luminous arms, its dynamic bar, and its hidden heart, we are not just observing an isolated star system, we are glimpsing the intricate interplay of forces that govern the cosmos. This galaxy reminds us that beauty and complexity arise from balance. Its structure, a harmonious blend of luminous stars, dark matter, and interstellar gas, exists because of an equilibrium between gravity, motion, and energy. The spiral arms, with their glowing star-forming regions, are the result of waves that propagate through the galaxy, compressing gas into dense, star-filled clouds. These arms are both ephemeral and enduring, constantly changing yet always maintaining their majestic shape, a testament to the galaxy's dynamic stability. The bar, a bold centerpiece that dominates its core, is a transient feature, destined to dissolve as the galaxy evolves. Yet, in its current form, it plays a pivotal role in shaping the galaxy's future. Acting as a cosmic engine, it directs gas and dust inward, fueling the nuclear ring, a hub of intense star formation and turbulent energy. This region, alive with the birth and death of massive stars, is a microcosm of the galaxy's larger cycles, a place where the forces of creation and destruction coexist in perfect balance. Deep within the core lies the galaxy's greatest enigma, a supermassive black hole. Silent and hidden, it exerts an invisible influence over its surroundings, anchoring the galaxy's nucleus and shaping the motion of nearby stars. Though dormant now, it holds the potential to awaken, unleashing jets of energy that could transform the galaxy's structure. Its presence is a reminder of the extremes of the universe, where ultimate darkness can coexist with brilliant light. Beyond its visible beauty, this galaxy is bound together by an invisible force, dark matter. This mysterious substance, forming an extensive halo around the galaxy, is the glue that holds its luminous components together. Without dark matter, the galaxy's stars and gas would drift apart, unable to sustain their rotation. This unseen component is not just a stabilizing force, it is a profound mystery that challenges our understanding of the universe. As we probe the motions of stars and gas, we are also uncovering the secrets of dark matter, piecing together the story of a force that has shaped the cosmos since its earliest moments. The galaxy's place in the cosmic web further underscores its interconnectedness. It is not an isolated island but part of a vast network of galaxies, clusters, and filaments that stretch across the universe. Its faint tidal streams and warped outer arms are evidence of past encounters, interactions with smaller galaxies that have left their marks on its structure. These encounters, though subtle, have shaped its evolution, adding mass, triggering star formation, and creating the patterns we observe today. But as majestic as this barred spiral is now, its future is one of transformation. Over billions of years, its gas reserves will deplete, and its star-forming activity will slow. The bar, a temporary feature, will dissolve, leaving behind a smoother, more uniform disk. The spiral arms may fade, their light dimming as the galaxy transitions into a quieter phase. It may merge with another galaxy, its identity blending into a new system, or drift in solitude through an ever-expanding universe. Whatever its fate, it will not be the end but a continuation, a new chapter in the story of the cosmos. This barred spiral galaxy is more than a celestial object, it is a reflection of the universe's endless cycles of change and creation. It reminds us that nothing in the cosmos is static, that every star, every structure, every ripple of gas and dark matter is part of a grander narrative. To observe it is to step into the mind of the universe itself, to marvel at the forces that shape not only galaxies but the very fabric of existence. In the end, this galaxy teaches us a profound truth: the universe is alive, not just with stars and galaxies but with stories, stories of how matter becomes light, how chaos becomes order, and how time weaves everything into the infinite tapestry of the cosmos. Its light, traveling across millions of light-years, is a message from the past, a whisper from the stars, inviting us to explore, to question, and to dream. It is a reminder that, as vast as the universe is, its mysteries are within reach, waiting to be uncovered by those who dare to look beyond the horizon.